guys, welcome to another video. Remember, it is always LoudPhysics when nothing else will do. In a previous video, we considered Ohm's law and the current voltage graphs of ohmic conductors. Remember, ohmic conductors are conductors that obey Ohm's law. In this video, we take it a step further. We are going to consider the current voltage graphs for non-ohmic conductors like a diode, the filament lamp, and a thermistor. We'd try to keep things simple so that you wouldn't have to do a lot of memorization. Let's kick things off by looking at diodes. A diode is a semiconductor device that allows current to flow in one direction but prevents current flow in the opposite direction. When the diode is positively charged or when it is forward biased, then current flows. If it's reverse biased or negatively charged, no current flows. We'll discuss more about these things when we consider electronics. From the current voltage graphs of diodes, the positive side of the graph shows a rise in the graph as current and voltage increase. That is when we have the diode to be forward biased, so there is flow of current as voltage increases. But this voltage or this current doesn't flow immediately until the voltage is about 0.6 volts, which is referred to as the threshold voltage. On the opposite side of the graph, the graph lies almost parallel to the horizontal axis, and that is when it is reverse biased or negatively charged, so no current flows in that direction. Even though not the full thing is depicted, it lies almost parallel, meaning no current flows because of resistance being very high for that side of the graph. So it is a curve, it's not a straight line, it does not obey Ohm's law. In the case of a filament lamp, the filament lamp does not obey Ohm's law like the first two we've considered. At higher temperatures for a filament lamp, the current voltage graph usually bends over as voltage and current increase. This means that the resistance would increase as current also increases, and that is going to make the filament hotter. What you need to keep in mind is that for each of these, because we are plotting current against voltage, the resistance is a reciprocal of the gradient, because resistance is voltage over current. And because we are plotting current on the vertical axis and voltage on the horizontal axis, to get our resistance, we need to find the reciprocal of the gradient of these graphs. So for the filament lamp, you can tell the gradient of the IV graph moves from being steep to being gentle. For the filament lamp, if we look at the gradient of the graph shown, it moves from being steep to being gentle. And what that means is that for the gradient for this particular graph, it decreases as we move upwards. So if we find the reciprocal, it is going to be increasing. And so resistance increases for a filament lamp as the filament lamp stays on and becomes hot. Its resistance increases. For thermistors, they are temperature-dependent resistors. The resistance decreases with temperature increase. At higher voltage ranges, when current flow becomes higher, the temperature of the conductor also rises, and this causes resistance to reduce. As a result, we have the current voltage graph bending upwards. The graph curves upwards, and what that means is that the gradient moves from being gentle to being steep. So for this gradient, it is increasing. If we find the reciprocal of the gradient, it is going to decrease. So for the thermistor, resistance decreases as temperature increases because it's a temperature-dependent resistor. So this is briefly what we wanted to consider in this video for current voltage graphs of non-ohmic conductors. I hope you enjoyed this brief video. Thanks very much for watching. See you in the